Interesting problem, and let's see how we can convert the ellipse problem to a circle and solve it, and then come back to the original world of ellipse. So here we go. We have an ellipse having equation x square by 9 plus y square by 1 equals 1, and you are given a line y equal to x by 2. So clearly y equal to x by 2 and the x-axis together with the ellipse will make an area. Let's call this area to be A. The question is asking about the value of slope m of line y equal to mx such that the area bounded by y equal to mx ellipse and y-axis is same as A. So we want these two areas to be equal, and we need to find the value of A. Clearly the question states that we are in the first quadrant, so our analysis is limited to first quadrant. Before we solve the problem, method 1 will be straightforward. You can basically integrate this. So if we'll draw perpendicular, we can integrate from 0 to, let's say, this value alpha, and that is fundamental area of this chunk, area of triangle, and plus we can find the area of this elliptical part. So it's upper curve minus lower curve. So from alpha to that point, which is 3, because as we can see, if y is 0, x equals 3, and if x is 0, y is 1. So we have length of major axis as 3, minor axis as 1. So one idea will be 0 to alpha, and this line we can integrate, plus alpha to that point 3, we can integrate y dx, where y will be 1 minus x square by 9, square root of that. Once you find the area, now do it exactly same for the y-axis. So here instead of y dx, we can do x dy. So area of this triangle plus, which is maybe integration from 0 to, let's say, that point beta, plus beta to 1, and we'll have x dy, where now x will be written as a function of y for this part, right? Because with respect to this, the lower curve is x equal to 0, and the upper curve is x equals 1 minus y square times 9 under root, which is 3 root 1 minus y square. Once you locate this, we'll get a value of m. But we are not going to solve this problem using this way. Clearly the solution by integration is quite lengthy, and we are going to solve this problem in a magical way. What we'll do is we'll convert this ellipse into a circle. Now you might wonder how we are going to convert this ellipse into a circle. So clearly you can see, as if the major axis, if I slap it by a factor of 3, so if I synchronize, if I descale the major axis by a factor of 3, this ellipse is going to convert into a circle. What I mean, let's say consider the following transformation: x dash equals x by 3 and y dash equals y. What exactly this transformation is telling you is, if I pick up any point on the ellipse, in the original xy coordinate system, its coordinate is given by x comma y. So what is x? Equals 3x dash, and y equals y dash. Now if you put this x and y in the equation of the ellipse, we have x square by 9 plus y square by 1 equals 1. So this will give you x dash square plus y dash square equals 1. Now clearly this becomes a circle. So this transformation makes this ellipse converted into a circle. So basically, in the language of matrix, although it's not required, but just for the essence of the subject, you can think like the point x comma y is converted into 1 by 3x and y. So the matrix operation will be 1 by 3, 0. We want x to be scaled down by a factor of 3, and we don't want y to change. So 0 times x and y times 1. So this is your crazy matrix, which takes up any point on the ellipse and convert it into a circle. Basically, any point on the entire plane is converted. Let's say if I talk about even this point, alpha comma beta, is getting converted into alpha by 3 and beta by 3. So even this line is getting converted in a new world, x1, y1. So let's say this is a new world, x1, y1. So now in new world, the ellipse in the first quadrant gets converted into the arc of a circle, or the entire ellipse gets converted into a circular region. Let's see what's happening to the point 3, 0 and 0, 1. clearly 3 comma 0 is getting converted into 1 comma 0, and we have 0 comma 1 over here. What about the line y equal to x by 2? So if I pick up any point on this line, let's say the point where this line intersects, which is alpha comma beta, or in general any point on this line will have the coordinate x as alpha and y as beta. So x dash is becoming alpha by 3 and y dash is y. So the line y equal to x by 2 gets converted into y dash equals so the line y dash, so we have x dash equals x by 3 and y dash equal to y if you have got any point on the line y equal to x by 2. Hence from this equation y equals x by 2 gets converted into y equals the value of x is 3x dash by 2. So we have y dash by x dash equal to 3 by 2. So clearly this is a line gets converted into line using this transformation. And now its slope has changed to 3 by 2. So basically what's happening, when this ellipse is skewed in this direction, horizontal direction, the line has also suffered a skewing change. And now exactly we know its slope is 3 by 2. So in this new world, y dash equals 3 by 2 x dash. So in this new world, y1 is, so in this new world, we have y1 equals 3 by 2 x1. Now let's see what happens to the line y equal to mx. Clearly y equal to mx will also get transformed into some line. But the beauty of the question is we wanted the value of slope in the original world such that these two areas are same. So if I convert this using magnification factor, if the initial area is, let's say A, so in the skewed world, area is just descaled by the same factor. So let's say this is if A naught by K, or if it is K A naught. We also want the value of slope such that this area is still K. So we don't care by what scaling it is changed. Actually, we know it, that will be by the factor of determinant of this. Okay, so area is also suffered a change by 1 by 3 factor. Anyway, whatever new area is, we want that area to be, let's say, K naught. So that should be same as this area K naught here. So in the new world also, we want the special value of slope such that these two areas is equal. Now the question becomes beautifully simple. Because from the symmetricity of the circle, clearly you can see for the area to be equal, it must be reflection about y equal to x line. So the slope of this line will be y equals 2 by 3x. So y1 equals 2 by 3x1. Why? Because if I take any point x1 comma y1, its reflection in y equal to x will be y1 comma x1. So the equation of the line in the reflection y equal to x will be y1 is replaced by x1 and x1 is replaced by y1. So we get y1 equals 2 by 3x1. So now I know in the circle world, the answer for which area will be equal is nothing but y1 equals 2 by 3x1. And now we are left with a very simple exercise to convert this line back to our original world. So we'll go to the original world via this linkage transformation. So let's see. So let's see what the line y equals 2 by 3x. So let's see what the line y1 equals 2 by 3x1 becomes in the original world, in the elliptical world. So now we'll make back substitution since we know x1 was x by 3 and y1 was y. So in the new world, y1 equals 2 by 3x1 becomes y equals 2 by 3 and x1 is x by 3, which is y equals 2 by 9x. And that solves the problem because we know in the original world y equals 2 by 9x was that magical line which will make equal area as same as y equals x by 2. So the answer for this problem is slope equals 2 by 9. The takeaway from this problem was great. Like how beautifully we have converted the ellipse problem into circle problem. You have to keep one thing in mind. By this transformation, which is usually in mathematical world known as affine transformation. So using this transformation, what is happening is area is just scaled by some factor and the angle is preserved. Okay, hence the slope has also preserved here. Somewhere the angle between two lines is still preserved, although their slope, individual slope is changing. Okay, so it gives a beautiful way of solving some problems, especially which deals with area and length. I'm giving you one more question, and you can give a try by yourself to convert it using this basic transformation. Let me pose you one very interesting questions. Let me give you one. Let me give you one more question, and you try to think how you can solve this question without a lengthy approach. And the question goes like this: you have 2 points, 0, 12, and 5, 0. Now we have a parabola which touches these two lines x and y axis and is tangent to these 2 points, let's say A and B. So clearly this parabola will be unique, and you can find the equation of parabola using properties, which I'm leaving up to you. I'll solve this problem in other video. The question goes like this: we have a line, parabola, and the axis divides this line exactly into 3 equal parts. So what I mean, if that point is P, let's say this is Q, R, and S. So we want PQ equals QR equal to RS. This is going to happen for many lines. So you have to find sum of slope of all possible lines. Give it a try. One hint I can give to you is, since these two guys are tangents, so this is 90 degree, right? So this point lies on directrix by the properties of parabola. Hence the line joining AB must contain focus. So let's say focus is some alpha comma beta. Now we know beta in terms of alpha because equation of this line is known. So beta is related to alpha. We also know the reflection of focus in any tangent will lie on directrix. So this reflection is alpha comma minus beta. We have other reflection which is minus alpha comma beta. And as you can clearly see, this will pass through this origin. And now these 2 points must be in the same line. And now it can be easily found because beta is already terms in alpha. So using properties of parabola, this distance will be equal to this distance. You can find the focus. Once you know the focus, you can find directrix. It can also be found by other way. The equation of parabola, like the tangent intercepted. Let's say we have any focal chord on a general parabola. Tangents drawn at point P meets directrix at Q. Then the segment PQ will make 90 degree at the focus of parabola. Okay, this is general property. So with that also you can solve the problem, right? Because this line will make 90 degree. So you already know this point 0, 0 and 5, 0. Beta is known in terms of alpha. So M1, M2 minus 1 directly gives alpha, hence beta. Anyway, once you solve for parabola, now you can take a random line y equal to mx plus c, or probably you can use parametric form to get the possible value of slope. But this approach will be quite lengthy. Still, I'll recommend you to solve this first with that method. So in next lecture, I'll come with a beautiful method of this transformation where I'll change parabola into a standard parabola by de-scaling it, and we'll solve the easiest version of that problem. This is a well-known technique in mathematics which is known as affine transformation. Okay, so basically with this affine transformation, we are able to solve most of the conic sections problem and convert into the easier version. I hope you must have enjoyed. Thank you.